The first concept we're going to go over is the components of a vector. The one displayed is a momentum vector with components designated as px and py. The equation of the magnitude of a vector is the square root of the x component squared plus the y component squared. The angle of the vector, or its direction, is the arctangent of y over x. Momentum is always conserved in any situation. This concept is called the conservation of momentum. This is indicated by initial momentum is equal to final momentum. Since the equation for momentum is mv, conservation of momentum in a collision can be indicated by m1 v1 plus m2 v2 is equal to m1 v1 prime plus m2 v2 prime. The following are just some of the basic equations we have for momentum and energy. First, we have P equals mv. Momentum equals mass times velocity. Next, we have force times change in time equals mass times change in velocity. Now for energy, we have kinetic energy equals half mass times velocity squared. And potential energy of gravity equals mass times gravity times height. And spring potential energy is half spring constant times compression distance squared. Force is equal to the negative derivative of potential energy with respect to x. On the screen now we have two graphs. On the left is a graph of potential energy plotted against position, and on the right we have the negative derivative of the graph, which is also the graph of force versus position. The important thing to realize while looking at these graphs is that the force is the negative derivative of potential energy, and potential energy is the negative integral of force. These equations are very useful in trying to obtain one of the values from a graph of the other. Thanks for watching Physics 1468 with Nikhil, Zuhayer, Shivam, and Taasin. But in case that explanation was too boring...
You want zero problems, big fella. Yep. If one more object try to stop me, it's gonna be some elastic collisions in your lab. See, you don't want collisions, no collisions with me. Peep. You don't want collisions, no collisions with me. Please get out the way, gotta make sure items stay still. There goes my momentum transfer to you, they like where to go. Energy's potential and it's mh times g. Energy's kinetic and it's related to 1/2 mv squared. Please get out the way, gotta make sure items stay still. Energy's not conserved every time, they like where to go. Ooh, watch me come and put the trains in their tracks. Counting meters while we meeting in the center, take my peep. Train is rolling, scooping all the friction out the ground. Man, don't you try to cheat, you shoulda never took a nap. What is your mass, what is your V, what you thought P was? You walk that make a physicist fall in love. No T though, yeah, you don't need time. Boy, it's real simple, P is equal to MV. Don't tweak, bro, it's always easy, bro. Momentum's always conserved, bro. If one more object try to stop me, it's gonna be some elastic collisions in your lab. See, you don't want collisions, no collisions with me. Pete, you don't want collisions, no collisions with me. Yep. Pull up and see 12 like energy's potential and related to G. Energy's kinetic and related to V. You don't want no problems, ain't no problems with me. Pete, you don't want no problems except from physics, see?